The objective of statistical inference is to draw conclusions about the population characteristics based on the information contained in a sample. We not only want to be mindful of the inference, but also the validity under which the data was collected. Drawing a valid statistical conclusion begins with defining the problem objectively and specifically. Next, decide if the problem will be evaluated by a one-tail or two-tail test. We need to frame a null hypothesis and an alternative hypothesis. Identify your test distribution and corresponding critical value. The critical value is a measure of the risk we are willing to accept if we are wrong. In other words, the alpha. We use the data to calculate a test statistic. Finally, we compare the test statistic to the critical statistic and make an inference as to whether the null hypothesis is to be rejected or not rejected. Every day, individuals are faced with decisions. While most people feel they can charismatically arrive at good decisions, the fact is that decisions made on gut feelings are often wrong. The null hypothesis is accepted to be true. The null hypothesis is denoted as H sub 0. The alternative hypothesis is the challenge statement. The null and the alternative are always mutually exclusive. They share no possible outcomes. The alternative statement is designated as H sub 1. Sometimes we will designate as H sub A. Our aim with any hypothesis test is to unseat the null through the collection of data that we hope will be compelling enough to reject the null hypothesis. Remember that hypothesis testing tells us what it is not what it is. We can reject or fail to reject a null statement, but we will never claim to accept a null or alternative. This gives us the wiggle room that comes with every statistical inference. After all, it is much easier to tell someone what something is not compared to what it is. The test statistic is calculated from the data. We collect data in the hopes of refuting the null hypothesis, never to affirm it. The critical statistic is derived from the alpha value. This is predetermined based on the organization's attitude toward risk. We will spend a great deal of time interpreting hypothesis tests. If a test statistic is bigger in magnitude than the critical statistic, we will reject the null. If it is smaller in magnitude than the critical, we will fail to reject the null. With every hypothesis, error is still possible. No statistical test is 100% certain. Framing these errors in terms of guilty and not guilty is a useful exercise. Two types of errors are possible. A type 1 error results when the null hypothesis is rejected when it is in fact true. A jury finds a person guilty when they are not guilty. A type 2 error results when the null hypothesis is not rejected when it should be rejected. A jury finds a person not guilty when they are in fact guilty. A type 1 error is quantified as alpha. Alpha is based on the risk attitude of the organization. Typically, you will see 0.05. More risk-averse organizations will go lower to 0.01 or even 0.005. A type 2 error is quantified as beta. 1 minus beta is known as the power. Power is the probability that we will reject a false null hypothesis.